Hello everyone, how are you doing guys? Am I audible?
Yes, you are audible. Yes, sir. We are fine. What about you?
I'm good too. How are you, Akif?
Alhamdulillah. Fine. I'm fine.
Good.
Yes, sir.
Okay, guys. Yeah, hi Prashad, hi Pankit, hi everyone.
Hello, good afternoon. Here,
Good
good morning
afternoon.
here.
Yeah, no issues. So, guys, just wait for 2-3 minutes
Okay.
for others to join. This is the first or second class, so then we're
Okay.
gonna start it up.
Right. Okay.
Meanwhile, we can have an introduction. So, guys, I hope every one of you knows me. My name is Shank, and I will be your instructor for this course. I am triple CCI certified CCI and routing switching service provider data center, and having overall experience of 13 years. Okay, so about you guys, I want to know about your name, your country, and total years of experience you are having.
This is Akif speaking. Right now, I'm doing job in UAE, and basically, I'm from Pakistan, and I have experience like 5 year plus experience, and I have experience in like MPLS, routing, switching, and firewalls also.
Okay, great. Okay.
Hi,
Next.
this is Dhanaraj from India.
Mm-hmm.
I'm 7+ year experience in network routing and switching.
Mm-hmm.
Right now working data center support.
Okay, great. Welcome.
Thank you.
Good morning. My name is Pankit. I'm from USA,
Mm-hmm.
and I've got like 7 years of experience, but mainly on layer 2 carrier Ethernet MEF for a Metro Ethernet forum.
Okay, great. Welcome, Pandit. So, any experience related to routing switching part?
Not hands-on, but I do have
Okay.
knowledge of routing protocols and switching because I've
Okay.
given my CCNA in routing and switch and security, but that's been a couple of years and it's been expired.
Okay. No issues. Welcome.
Hi, this is Prasad here, working in UAE. I have around
Mm-hmm.
18 years experience working as network security engineer.
Mm-hmm.
My
Okay.
core domain is with Fortinet and Juniper.
Okay. So, any experience in Cisco?
Yeah, I do have worked
Okay.
in routing and switching, so not that much as.
Okay, great.
Hi, this is Mohan Prasad, and I'm from India. I have 9 years of experience in routing, mostly into routing protocol testing, up to some extent switching as well.
Okay, great. Welcome. Okay, guys, some more people will join, but let's start with the class. Okay, format is gonna be like at 9 p.m. sharp. I'm gonna open the link and we're gonna start within 5 minutes. Okay, daily, because some people will join little late. So I'm gonna give you a buffer of 5 minutes, but not more than that. Okay, class is gonna be a mix of both theory and lab practical part. Okay, first we're gonna go with the OSPF complete from CCNA up to the CCI level. Okay, and then we're gonna go with after that we're gonna go with BGP from CCNA to CCI level, and then we're gonna go with MPLS from CCNA to CCI level of enterprise. Okay, so service provider is having more topics which we're not gonna cover as a part of this. Okay, for MPLS only. Okay, and you guys must have got a portal access. Okay, if you're not get it in 1 or 2 days, you will get it. Okay, so do not worry about that. You will get one welcome email, and then in that email, those who already like, I think every one of you is already enrolled, right? This is not a open class. This is a locked class. So you will get a welcome email. Okay, in which you will have different accesses like lab access, portal access, and Slack access. Okay, I'm available on Slack. You can ask me question anytime on Slack. Okay, whenever I see your message, I gonna reply you that. I'm not there on WhatsApp, guys. Remember that thing. We're gonna use the same link for all of our classes, but in case if we want to change the link, we're gonna update you on WhatsApp and Slack both. Okay. So now Before we start, do anyone of you have any question, any doubt you can ask? Then we're gonna start.
So will you also be providing like material and theory wise,
Yes.
all the notes and
Yes.
everything?
Yes. So theory wise, I'm gonna provide you we are having a material which is also gonna be uploaded on the portal. Okay. There is a link of Google which you're gonna get it. And lab workbook is also gonna be provided. You will have lab access as well, which is 24/7 available. Okay. So that will be there till our course end. Okay. So that is we're gonna provide to you. Yeah. Any other question?
Shank,
Sorry. Saying there was an option to download the lab to a home laptop. So
So
that also. So how to do that?
yes, so we are having a dedicated lab instructor. You can contact them. I'm gonna give you the email ID. Okay, and he gonna help you with that. You can get the topology. Okay, iOS you need to arrange by yourself. Okay. Yeah. What else?
Shank, one thing,
Mm-hmm.
like the idea of joining this course is mainly for traffic engineering for myself, MPLS. But I could see better that you are covering up to some extent of MPLS. Is there any
Right.
chance that you will cover traffic engineering, or is there any separate class after?
Okay. So if you need, I will cover that topic for you. No issues.
Okay, thank you, Shank.
Okay. So basically we are covering it up to the layer 3 VPN, but okay, I will cover MPLS traffic engineering as well.
Okay, thank you very much, Shank.
Yeah, welcome. Okay. What else, guys? All good to go? Okay. So then let's start with the course. So,
hello, sir.
yes, Akif.
Sir, OSPF sham link. Huh?
Mm-hmm. I'm gonna do that. No, don't do
Okay,
that.
okay, okay.
Okay. So let's start. Let me share the screen. So this class is from Monday to Thursday. Okay. And although the duration is for 3 weeks, but it can go up to 4 weeks. Okay. Because guys, it depends on you as well, how you are responding. And although we are having a pretty much decent experience here, right? Every one of you is having above 5 years of experience, if I see. So there is no issues. Basic things I hope you guys know. Okay. Anyways, protocols are gonna start from the scratch. Okay, so today we're gonna start with the OSPF. I hope everyone able to see my screen, right?
Yes.
Yes.
Okay. So everyone know OSPF stands for Open Shortest Path First, right? It is an open standard and a link state protocol. So open standard we everyone know. Okay, that means it can work on any vendor router or switch or device. Okay, what do you understand by link state?
It advertised
And
the link. It advertised the link information to its neighbors, like the link status, or all the things related to the link subnet interface to its neighbors. Yes.
okay, and how it is different than your distance vector routing protocol. And by the way, guys, I keep on interacting a lot with the persons. Okay, and you can stop me anytime. Do not wait for your questions to be at the end. If you don't are able to understand, you can ask me immediately. Okay, so that is the flow of the class I usually follow. Okay, yeah. So what is the difference between link state and distance vector?
In the distance, it is like a hope to hope. It counts like hope, like how many
Hmm.
hope in between from source to destination.
Mm-hmm.
But the link state is different. It doesn't like matter like how many hopes in between from source to destination. Maybe there are five nodes between source to destination, but they are having the less cost if we will add them.
Mm.
Yeah.
So, but what is exactly the difference?
I think the difference would be that when there is any change in a distance vector, the whole routing table is sent, updated and sent, or routing table is sent to all the neighbors or to nodes.
Mhm.
But in link state, only the the change, what link is change is sent, not the whole table itself.
That is partially correct actually. What else?
Like it supports trigger updates. Like if the particular version, it supports the trigger updates.
Okay.
While in the distance
you-
vector, it is like advertising the complete routing table.
What else?
The whole topology is known in link
Mm.
state and in route in distance vector, not the whole topology, only the topology of your nearest neighbor, the first connected
Okay,
neighbors.
so that is the most important difference which I need to hear. The in
Okay.
link state, you will have a complete map. Okay. Your routers are having a complete topology in its database, which it got from different routers, neighbors. In distance vector, you will have, you need to reach to the next stop, okay, and then next stop is gonna need to reach next stop, okay, like that. So they don't have the complete map, okay. So that is the most important difference, okay. Apart from that, guys, your again link here means interface. And by the way, guys, these notes which I am writing, you can later on take, if you want, you can take the screenshot from the recordings. Okay, all the classes will be gonna be recorded, and you can take, because I'm not gonna save these things. Okay, so if you want, you can take the screenshot. Okay, so link is gonna be interface, and state is gonna be information which can include a lot of things. Okay, it can include your subnet, it can include your mask. Okay, it can include your status, it can include your what else, guys?
Subnet IP information.
Okay, so subnet, mask information, your prefix, what else? So a lot of things are there, right? We're gonna see that. So that is it gonna send to your neighbor. Okay. OSPF do not use TCP or UDP. It directly runs over IP. Okay, and in IP header, the protocol number of OSPF is gonna be 89. Okay. How OSPF is gonna send this update to neighbors? So by default, it's gonna send it over multicast address. Do anyone knows what is the multicast address?
Yeah.
124005 or 6 and 6.
So 224.
Sorry,
0,
224.
0,
My bad.
yeah,
6.
0, 5 and 6. We're gonna talk about why these are two different addresses. Okay, so that we're gonna talk about. And it can also send updates via unicast. Okay, for that you need to enable it via neighbor command. We're gonna discuss that in detail as well. Right now, I'm just telling you the basic points. Later on, we're gonna discuss on every point in detail. Okay, so that we use in NBMA networks, which is known as non-broadcast multi-access networks. Okay, so those we're gonna discuss what are non-broadcast multi-access networks. Okay, then OSPF can do equal cost load balancing. Okay, so that only it can do equal cost load balancing. It cannot do an equal cost load balancing. Then triggered updates, you already told. So whenever there is a change, okay, it's gonna send that change, and only that change is gonna be updated. But there is a periodic update as well. Do anyone knows what is the time for that periodic update?
Maybe 30 seconds, 30 minutes or 30 seconds, I think.
30 seconds, I
That
guess.
is gonna be 30 minutes.
Yes, 30 minutes.
And the max age, which means it's gonna hold the update in its database, is 1 hour. Okay, after 1 hour, it's gonna flush your LSA. What is the AD value in OSPF? By the way, guys, if you not know what is AD, you can ask me. Okay, so if anything you not know, please ask me.
110.
Okay,
10.
so AD value is administrative distance, which is 110 in case of OSPF. Then which algorithm OSPF uses to calculate the shortest path?
SPF.
Digistrus.
Okay, so Digistra's SPF
Yeah.
algorithm. Okay, so Digistra's SPF algorithm it uses. Okay, so these are some of the basic points related to OSPF. Anyone having any doubt, any question in this? All good? Okay, guys, you need to give me the confirmation, then I can move on further. Okay.
Yeah.
Yes, sir.
Okay, thank you. So after that, let's now discuss about advantages and disadvantages of OSPF. What do you think, guys, are the advantages of OSPF?
Open source. It can go
First
to
one.
multi vendor.
Okay, so open standard, which can you multi vendors can use. What next?
Faster
Like the
conversions than IBGP.
So it has faster convergence than any other protocol.
Isn't doesn't EIGRP have better conversion than OSPF?
So you tell me first, what you think?
I think because upon what I read, I think EIGRP has faster conversion than OSPF. That's why I was thinking. That's why I said
Because
IBGP.
yeah, because it is having feasible successor.
Right.
There's a conversion chart, but I need to check again. Okay, I will confirm you that thing tomorrow. Okay.
yeah, EIGRP is the fastest convergence.
Yeah. Okay. But anyways, guys, all over the world, OSPF is used more as compared to EIGRP. If I
Exactly.
yeah,
Yes.
I also like in my 13, 14 years of career, I have checked with other colleagues as well. And I always ask them what you are running as a protocol. So OSPF is used a lot. Okay. What else?
Like it's a very versatile protocol. Like we have the concept of areas. So according to that, like according to the requirement of our network, like we can configure the things.
Mm-hmm.
To make it sure easy to configure, not complex.
That is, we cannot say as a. Okay, so it can support your large network size. So what do you understand by that? There is no hop count feature in OSPF.
Unlimited output, right?
Unlimited hop count, you can create n number of routers like 500, 600, thousands. You can connect it. By the way, how many routers you can have? Have you ever seen in one area in OSPF?
It's 40 to 50 recommended.
So okay, so 40 to 50 recommended is. Do you know when that recommendation come?
Like when we will have so many routers, like hundreds or thousands of routers.
So that recommendation comes in 1992. Okay, which means
Okay.
30 years back.
Okay.
Right, and that is based on your 2500 series routers. Nowadays, you can go up to around 1000 of routers in an area. Okay.
That's great.
So,
But
even
in that case, what should be the router types? Like it's memory, or it should be
yes,
like
that
better, right?
yes, that we're gonna discuss. Okay. Okay, guys. Any other advantage you think of OSPF?
Like we can use like with the MPLS also in case for traffic engineering or for other things.
If I
It's
want to
both
run EIGRP with MPLS, can I not run it?
for the traffic engineering it will not work.
Why?
But as per my information, I think no, it will not work.
You should give me a solid reason for that. Okay, so try, let me know tomorrow.
Like it is having like different type of LSAs, and that LSA support this traffic engineering. EIGRP is not having like much
Okay.
versatility. That's
So
why.
LSAs are increased like type 8, type 9, type 10, which is opaque LSAs.
Exactly.
It's
Yes.
used for MPLS traffic engineering, which is just because OSPF is running in the background. So to support that, they do it, but that is not actually the reason. Okay. Anyways, no issues.
Okay.
So
And
hi PT,
OSPF
I
is
hope
a
you joined late. Just a
centralized
second, guys.
structure.
Just a second. Preeti is joined. So hello, Preeti. And how many years of experience you have, Preeti? Okay, so maybe she's on mute. Okay. Yeah, someone
Yeah,
saying.
hi. Yeah, hi,
Hi.
how are you?
I'm good.
I have a total 8 years of experience, but then I
Okay,
have
great.
a gap of 2 years. So I
No
want to
issues.
refresh my OSPF EIGRP.
Okay, no issues. So yeah,
And
that is what
I'm really
actually.
sorry for
No,
and
no
I'm really
issues.
sorry for joining late.
Okay, no problem. Okay. Yeah, Mohan, you were saying something?
OSPF has a centralized network structure when it compared with other linked state protocol ISIS.
So what do you understand by centralized network structure?
Like hierarchical and its structure, like all the areas will connect to area 0.
Mm-hmm. So hierarchical design, I can
Yes.
say. Okay.
Yes.
Okay. What are the disadvantages you will find in OSPF?
Consuming more memories due to the having all
So
the any change in
consumes more memory, CPU. Okay. What else?
And OSPF really works within the area. It is a linked state protocol. Among the areas, again, it's not a linked state. It's work as a distance protocol.
So how it is a disadvantage? Anyways, other protocols are already doing the same thing.
I believe, if I'm not wrong, it requires a lot of information. It requires like more information compared to other routing protocols to
So
calculate the
that,
best path.
okay, so calculation is done. That's why we are putting more memory and CPU. So that point comes there.
Okay.
What else?
other areas must connect to area 0, then only
That
it
is
will.
not a disadvantage.
As it is a link state, it has only the information from the next connected routers. So it may be
That
a
is again, that is an advantage. That is not a disadvantage. So
It only
one,
supports equal cost load balancing,
yes,
and
that
not
is the most important disadvantage. Okay, so only equal cost load balancing. Okay, so this is one of the most, and even if someone asks you in the interview that what is the one thing which due to which I will not choose OSPF instead as compared to EIGRP. Okay, so this is the most important thing. Then the third one is you will have summarization only at ABR and ASBR. Okay, so if you don't know what is ABR and ASBR, I'm gonna talk about in just 10 minutes. But you cannot do summarization at any router in OSPF. Okay, that is also one of the disadvantage. Okay.
And also, there is no option to auto summarization. You have to do it manually.
And yes, so auto summarization is no there. No auto summarization. Okay. So these are some of the advantages, disadvantages. After this, let's talk about the OSPF tables. So what are the tables you will have in OSPF?
Sir, I didn't take the screenshot.
You can take it later on, do not worry.
Okay.
Okay, all these things are going to be recorded, and
Okay.
within 12 hours, you will get the recording on the portal.
Okay, then
So
fine. Okay.
yes, okay, on the
Okay, then fine.
portal, You can take whatever you want. Okay, do not worry.
So nice of you, sir. Okay.
Okay. So OSPF table. So guys, tell me what are the different tables you will have in OSPF? Again, guys, I am assuming these are very basic stuff, but again, if you don't know, that's okay.
Topology table.
Okay, so topology table, also known as database table.
Neighbor table.
Okay, so database table. Then the second one is gonna be your neighbor table. Okay, and then you will have a routing table, which is again not a OSPF table, but again, if we selectively want to see the routes of OSPF, we can do that. Okay, so topology table is you can see it with show IP OSPF database, right? Then your neighbor table is gonna be having the neighbors, show IP OSPF neighbor. And if I want to see specific OSPF route, show IP show IP route OSPF. Okay, so these are the three tables which we are having. And so this is a complete map, okay, complete picture of your area. And again, we're gonna talk about what is there in that. Okay. So after this, let's talk about OSPF areas. So first of all, we're gonna talk about two areas, okay, which are your backbone area and
Standard area.
standard area, okay, or you can also call it as regular area. And then later on, we're gonna talk about some of the more special area types, okay, which
Yeah.
is stub area, totally stub, not so stubby, okay. So
Yeah.
those things we're gonna later on discuss in the course. Okay, guys. So first of all, why we need areas?
To reduce
Three
router burden.
Three reasons you need to tell me three. Okay.
First of all, to avoid the loop, we can avoid the loop through this.
Okay. What else?
To reduce router memory utilization.
Memory CPU utilization. Okay.
For better management or troubleshooting purposes.
Okay, so you can say that. What else?
Is the complexity of the network.
So again, better troubleshooting, we can say it in that. So it's gonna localize your topology change into that area. Okay.
Can you explain this, localized topology change?
Okay. So if anything change is gonna happen in your topology, it's gonna be your LSA. Right now, if you don't know what is LSA, okay, so you can say like update is gonna be only impact in that area only.
Okay, got it. Okay, nice.
Okay.
Yes.
So your LSA, detailed LSA flooding or detailed update flooding, you can say like it's gonna stop at the border router. Okay.
Yeah, got it.
Doesn't that depend on the type of LSA it will go?
So again, even if you talk about the type of LSA, then again, it's not gonna send everything.
Okay.
Even if it is type 3, then also it's not gonna send everything. Okay.
Okay.
So type 1, type 2 will not go beyond your area, right?
Yes.
For type 3, it's not gonna send everything. Okay, it's just gonna send the summary. Not the prefix summary, but the topology summary. Okay, there is a difference between prefix summary and topology summary. Okay. Again, we're gonna talk about. Okay, guys. So what is backbone area?
Area 0.
Area 0 is the backbone area.
Okay, so area 0 is gonna be your backbone area. And if you talk about in our environment, like in enterprise or a service provider, okay, basically mainly it's gonna be used in your core layer. Okay, because again, if you are having SVI or your layer 2, layer 3 demarc at the distribution layer, then normally you are running layer 3 between your core and distribution. Okay, right? So those layers is gonna be where you will have a backbone area which will have no end users. Okay, so normally we'll not put end users in this one. Even if you want, you can do it. Okay, there is no compulsion, but normally we not put. Okay, it is also known as transit area.
Yes.
Okay, so this is related to backbone. What is your regular area?
Like for backbone area, like it is a condition like all the areas must connect to the backbone area. But one
So
standard
again,
area, yes.
first of all, you need to tell me what is regular area.
This is like a distributed layer. If you say service for
Hmm.
enterprise, the how backbone is core, regular should
Hmm.
be distributed.
Or you can say like all other areas, right?
All other
Ex-
areas.
Okay.
remaining of everything.
Yeah, simple.
Yes.
Yeah.
Or I can write non-backbone area.
Okay.
Okay, now let's come to the condition which as Akif is saying that there is a condition that every area should connect to area 0. So why is that condition?
I don't think that is necessary because you
Mhm.
can have one on you can have one area which is just connected to another standard area, and then that the other, say you have a backbone area connected to a standard area, and that standard is connected to another area. That it the third area can be connected to the backbone via virtual link.
Hmm. So virtual link is a concept, but again, even if you are using virtual link, what you are doing behind the scene?
It's connecting to the backbone area.
So then again, you are following that condition which every area should connect to your area 0, either physically or virtually,
Okay.
So
right?
if we have only one single area, means we don't need any area zeros. We can use any areas.
Sure.
More, yes, more than two areas, we need area 0 to communicate.
Okay. Then why you need area 0 when you need two areas?
It manages the other two areas.
No.
Because OSPF has to maintain create a neighborship, so maybe because of that they should be one master, one slave in that case.
No.
No.
No, like it depends. Like one area is having a less number of routers, or the routers which are having low memories, or that area can be the stub area, or that area can be like managing your branch. So in that case, like you have two
That's
different.
okay. You will have a different. You're getting my question. First of all, tell me what is my question actually.
Yes,
The
can you?
question the question is basically, if you have two networks, why do you need one area 0, and why can't you just have everything in one area? Why do you need one area 0 and one no standard
Mm,
area with for two routers, right?
No. So my question is why every area needs to connect to area 0.
Oh,
To avoid the loop.
Mm-hmm.
Area
No.
0 only having all the routes to reach other areas.
Yeah,
Mm-hmm.
to avoid the loops also, and
So how you're gonna avoid the loop via area 0?
like because each area is having information, like it is coming from that area. So
So in my topology that I have drawn just now, don't you think we are having a loop here?
It manages the routing tables, right?
Mm-hmm. Okay, so answer is correct that to avoid the loops, first of all. This is the only design through which OSPF is gonna avoid the loops. But now you tell me how it's gonna avoid the loop. Don't you think this topology has the loop? So for example, I am having one prefix here in my R2 which is 2222, okay, which I am advertising in area 0. So that prefix goes here, then here, 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 and here. So now this is a loop. How your area 0 is avoiding the loop?
Like it is having information, like it is coming from other area. So that's why like it will not create loop.
So even this prefix is right now is running with like I have took it in area 0. If I took it in any other area, then
Is it to do something with ABR and ASBR routers, like how they exchange
Hmm.
information?
so forgot about ASPR. As of now, we are having only ABRs. But again, yeah, there is some concept with that.
So the ABR is like advertising the summary of that
No,
network.
no, forgot about something.
This is something
Uh,
related to
Is it that the area maintain the detailed information about the links
Mm.
and the routers, and other area don't have that, information?
So,
The
but
area 0.
how that is gonna avoid the loop? That is correct.
Because
Mhm.
yeah, because if it has all the information, it can send information to the adjacent routers of the others area, like area 1 or area 2. So in this way, it can avoid the loop.
But here, if you see, I am getting a loop. How that is loop is you will avoid here. I am going as per my design rule. Okay, every area should connect to area 0. I have connected every area to area 0. Now tell me how this green circle will avoid. You can be avoided, or automatically it can be avoided. There is one concept.
Rita, is
Yeah,
it
it will be automatically avoided, but I don't know, like it's not coming in my mind. Like,
R5 doesn't forward
Yes,
file.
yes. Okay. So that is the concept. Your areas is not gonna exchange the routes with each other. They only gonna exchange the routes with area 0.
okay.
Okay.
Yes,
That's why area 0 is known as transit area. Your area 0 is only allowed to exchange the routes of any other area to any other area. Okay, like if you generate one route here, which is 6666, that will go here, here, here. Okay, and then from here, your area 0 is going to exchange that to area 1. Okay, so that will not go via that way, this below way. Okay, this is not allowed. This is how it gonna automatically avoid the loops. Okay, that's why every area needs to connect to area 0 either physically or virtually via virtual link. Okay, if you guys not know what is virtual link, we're gonna talk about that in detail. Okay, but this is the concept which a lot of people will not know. Okay, so that is why area 0 is needed. Okay. After this, let's talk about router type in OSPF. So we will have internal routers.
backbone routers.
So internal routers are the routers which have all interfaces in same area. Then you will have backbone router, which is router in or connected to area 0. Then you will have ABR, which is area border router. Okay, so interfaces in multiple area. Then you will have ASBR, which is Autonomous System Boundary Router. So this is a router which is gonna be a redistributing router, which is redistributing route from any other routing protocol to OSPF. Okay, guys. So now to understand these, again, let's take it here. Or let me draw one more for you. And here I am running EIGRP. Okay, so you guys need to quickly tell me all these 4 routers type. So what are internal routers here?
R2, R4.
Yeah, R2, R4.
What about R1?
R1 would be an ABR. It's a border router. So it'll
So
be
right now
connecting
it
two
is
areas.
not. So right now it is not
The
connected to
R1,
any area.
R2, R4.
Okay. So
Okay.
R1, R2, R4. What
Uh,
are your
I
backbone? Sorry.
I did not. Why is R1 part of internal? Because it's on the border, right? So
Yes,
won't it
but
be like
right now there is only one area which I have shown you, right?
okay?
No other area is connected. So unless
So
until the other area is connected, it's not going to show you as a ABR.
okay.
Okay, what are backbone routers?
R2.
R1, R2,
R1,
R3.
R2, R3.
R1, R2, R3. What are ABR here?
R3,
R3,
What are ASBR?
R5.
R5.
Okay, so this is going to be your ABR, and then this is going to be your ASBR. And your ABR is going to hold both the areas topology. Okay, so that is having the database which is having for both the areas. Okay. So anyone having any doubt, any question till this point?
Did you say R5? It holds all the database for all the other.
I'm saying about ABR only, not
3.
ASBR.
Can you
Yes.
please repeat that what you said, Shank?
So yes, I was saying like, okay, first of all, let me tell you that your routers which are having in a particular area is having a same database. Okay, because all are having whatever routers you are having in a particular area, you will have a same database which is there for that area only. Okay, this is the first statement. The second statement is your ABR is going to hold database of whatever areas it is connected to. So in our diagram, if you see, R3 is going to have the complete information of area 0 and complete information of your area 1 as well. Okay, we're going to see that thing in lab as well. Okay.
So like as we said that it's a link state to pass all the link updates and every router has the full view of the topology, right? So if want R3 pass its information of all of area 0 to R4 as well. So want R4
No,
eventually have the same information as R3.
no. So your ABR is not gonna pass the full information. It's gonna summarize the information. It's not gonna summarize the prefix. Okay, it's gonna summarize the topology information. You're getting my point? For example, let me explain you one more point here. This is a very important point, which people will not know or not able to understand. So R4 is your ABR here. Okay. So if R1 is sending one route, whatever is the route, /24, let's take. So when R4 is gonna send that route as a type 3 LSA, okay, again, guys, I'm gonna explain it later on, but it's okay. Okay. So when it gonna send this route to the other area, what information it gonna summarize? Okay, it
Hello.
gonna information. Yeah, you able to hear me?
Yeah, actually I was
Okay.
not able to hear you. Okay.
Okay. So what I was saying is when R4, which is your ABR, wants to send the information to the other area, what it gonna summarize is it's not gonna tell the topology of other area. Like in case when the update goes to the area 1, R4 will not tell to R5 that R1 network is reachable via R2 or via R3. That it gonna summarize. What it gonna tell is if you want to reach 1110, send the packet to me. Okay. So this is known as topology hiding, topology summarization. It is different from your prefix summarization. Understand that point. If I am having 112.0, 113.0, if I am having these three prefix, all three prefix will go into area 1. It is not like it's gonna summarize those into one update. Getting my point? What it gonna summarize or what it not gonna summarize.
Okay. Yeah, understood.
Anyways, this point I'm gonna discuss later on when we do the LSA types. Okay, so
Okay.
do not worry. But this is what happens. Okay, so your other area will not have the picture of any other area. Okay, they only have the picture of their area only. So what we call it as a topology map. Okay, or the complete map is only for that area. That's why someone said in the beginning that between area, it works as a distance vector. You're getting my point?
Oh, okay. Now it makes sense because I thought if
Yes.
it's topology, then every router should have information of every
Yes.
other router
So
regardless of area.
every router is having information of every other router within that area only. Okay.
Okay.
It
So
will
if
not
it's
have the picture of any other area.
okay, so between area, it's like it works similar to distance vector.
Right, right. So
Okay.
between area, it is distance vector. Within area, it is link state.
That is a very important point.
Yes. Anyone here who not able to understand this point? Because what happens is, you know what is type 3 LSA? What is the name of it?
Network LSA,
Network sum
network
network
summary. Is
summary
it?
LS.
So people will confuse, 99% people will confuse what is this summary means. This summary doesn't mean that for these three prefixes, you will make only one, you will only send one update. Your all prefix will go to the other area. This summary means topology hiding. How you want to reach to these prefixes, this is what our ABR, your ABR or R4 is gonna hide from other area. Means you will have these two paths. Okay, one is via R2, one is via R3. So this is it hides. Okay, that is what it means of summary here. Getting my point, guys?
Yes.
Okay, now coming back to where we are. Okay.
Hello, sir.
Yeah.
Maybe you will tell it later, like, but there is one concept like neighborship and
Mm,
adjacency.
mm,
So what is the
yes.
main difference between that? Like,
So neighbor is any where whatever is the neighbor on your router means on your interface. Okay, this is your interface of a router,
yes.
and this is another interface. Okay, so these are known as neighbor. But
Okay.
adjacency is gonna be formed in OSPF when you will have both sides hello receive, and when they go into your bi-directional communication.
Sorry, can you repeat?
When you will have both sides hello complete, so there is a complete OSPF states, right? We're gonna talk about that, which
Okay.
starts from down, then init,
Okay.
then
Okay.
two-way, right? Start,
Okay.
exchange, then loading, then full. So after
Mhm.
this, they're gonna make a full adjacency.
Okay, right.
Neighbor, you can say it like the interface which is connected to the other side is, so you can say R2 is my neighbor. Okay, but adjacency is going to be formed after these states.
Okay, got it. Yes.
Okay.
Yes.
So after this, let's talk about OSPF metric. So what OSPF use as a metric?
Cost.
Okay. And lower is preferred or higher is preferred?
Lowest.
So lower cost is preferred to the destination. Okay.
Yes.
Now, how you're going to calculate this cost? So there is a formula. Formula is going to be 10 to the power 8 upon bandwidth in BPS, which is bits per second. So guys, you need to now tell me what is this 10 to the power 8, how this 10 to the power 8 comes. So there is a logic behind that. So guys, if you are teaching with me, I'm not like, I just gonna tell you that this is that, this is that. Okay, I'm gonna tell you the logics behind that. I hope that is gonna take 1 or 2 classes extra, but it gonna makes the concept clear in your mind. I hope you guys are okay with that.
Yes. Sir.
Okay, so how this 10 to the power 8? Can anyone tell me or anyone know?
I do not know.
Okay. Okay. So what is gonna happen here is this 10 to the power 8 comes because there is a concept of reference bandwidth in OSPF. So there is a reference bandwidth which is gonna calculate your cost. Okay, and by default, when the OSPF comes in 1990s, at that time they took reference bandwidth as 100 Mbps. So convert 100 Mbps into kbps. Tell me what is the figure. Right? If I'm not taking 1024, I'm just assuming that 1000 is equivalent to kbps. Okay. So this is what 100 Mbps I can write like this. Any issue with that?
Okay.
I can write or I cannot write. First of all, tell me guys.
You can write like that, or you can write 10 to the power 5.
Yeah, that is okay. But first of all, people will understand that thing. Because again, 1 Mbps equals to
1000 kbps.
1000 kbps. Actually, it is 1024, but let's take it 1000. Okay. So that's okay, guys. Okay. Normal math. Now, if I want to write it into the bits per second, what is going to be there? Because 1 kbps equals to 1000 bits per second. Right? Normal math. So what is that total 10 to the power?
8.
Okay. So this comes here. Because we are referring the bandwidth into BPS. Because on the command line, when you put the bandwidth, you're going to put it in BPS. So this formula is going to calculate the cost. So when you start calculating the cost with this formula, for example, you are having a serial link of T1. Okay. So it cost will come 64 when you calculate with this formula. If you calculate with Ethernet, so Ethernet is what? What is Ethernet? In terms of Mbps, if I talk.
10
Mbps. 10 Mbps.
Okay. So 10 to the power 8 upon bandwidth you need to find in bits per second. So 10 to the power 8 upon what is the bandwidth in bits per second? 10 Mbps if you convert in bits per second, what it comes?
10 into 10 to the power 8.
not 8. 10 Mbps. Mbps I can write 10 to the power 3 kbps. Okay. Then this I can write as 10 to the power 3 bps. So what is the total? 10 to the power 8 upon 10 to the power 7. What comes? What is the answer of that?
10.
10.
Okay. So your cost will come 10. If I do fast Ethernet, what the cost will come?
10
100
to the power
Mbps.
8 upon 10 to the power 8, 1.
If I do gig Ethernet, what the cost will come?
0.1.
Okay. If I go 10 gig, what the cost will come?
That is
0.0.
0.01.
What is if I go 100 gig?
0.0.
0.01.
So I hope you are okay with that. Now there is a problem. Your cost will never be in the points. So you need to make it round off. So basically it cannot go below 1. So you need to put it 1 here. You need to put it 1 here. You need to put it 1. So now this is a problem for us. What is the problem with this?
Fast Ethernet gig, everything is on the same cost. So if you
Okay,
want,
so R1, R2, R3, I am having 3 different links. One is 100 Mbps, one is 10 gig, one is 100 gig. Where it gonna send the packet?
it will do
It's
equal cost load
usually
balancing.
do equal cost ECMP.
Okay, so it will do equal cost load balancing. So then what is the use of getting 100 gig link if you're not able to use it? You're getting my point.
That is the problem.
That is a problem. So now to solve that problem, you have solutions.
Yes.
What are the solution? The solution is this reference bandwidth, you can set it up. You will have a command over which you can set this reference bandwidth.
We can
By default, it is 100 Mbps, but you can change it as per whatever is your highest link in your infrastructure. So recommendation is you need to change it. But again, there is one point here. If you change it on one device, then you need to do it on all the routers in your area. Otherwise, rest routers will calculate it as per 100 Mbps only. You getting my point, guys?
Yes.
So this is your one solution. Okay, so the solution for our problem is reference bandwidth. Reference bandwidth we can change. Okay, and if we want to change, then change it on all routers. Then there is another solution as well. What is that? Anyone knows? Okay. So another solution is directly you can change this cost. Forgot about reference bandwidth. Directly on the interface level, you can change directly cost. There's a command for that.
Then why would we then? It's better to directly change cost than change refer bandwidth, right?
Yes, because again that you need to do it only between two neighbors where you are
Right.
having a link.
Right.
But again, both ways are correct. Even you can go with reference bandwidth as well. So then there is an automation comes where you need to make a script that will make changes to all of your routers in an area. Okay. So again, guys, per neighbor as well, you can set it up. Okay, or reference bandwidth, you can also use it. When you change it, reference bandwidth, it's gonna take it in Mbps only. So if you want to give 1 gig, what you gonna give? So if you want to give it as 1 gig, you need to give it as 1000 Mbps, okay? Because your interface, your reference bandwidth, when you put that command, it's gonna take it in Mbps only, okay? Anyways, that you will get it. It will show that you need to fill it in Mbps, okay? Okay, guys. So all good till here?
Yes.
Okay. So one more topic, then we're gonna, I think, because again, 1.5 hours is gonna be a class, and tomorrow we're gonna do some lab as well. Okay. So next topic is OSPF packets. So guys, first of all, before doing the packets, again, this is the CCI stuff. You will not find mostly in the CCNP or CCNA books, okay? Which is, you will have a IP header, okay? Then after IP header, if I make a complete header, then you will have a layer 2 header, right? Then you will have a layer 3 header, which is known as IP header. Then after that, your OSPF starts because it not uses TCP and UDP, okay? So that is your OSPF header. Okay, so what is OSPF header is gonna tell that your next packet is gonna be a OSPF packet. Okay, this is the role of header basically. So after that, whatever is the OSPF message or data or packet you can write, okay, which comes. So now what we're gonna do, we're gonna talk about this packet types. Okay, so what are the different packet types you will have in OSPF? So you will have hello packet, you will have database description packet, you will have LSRs, you will have LSU, you will have acknowledge. Okay, so we're gonna talk about these 5 packets types which you are having. And those who think like where is LSA? So LSA is not a packet type. Okay, LSA is gonna having a information which comes inside LSR. Okay, which is link state request. Again, we're gonna discuss about them one by one. So let's first talk about hello packet. So what do you think, guys? Why we use hello packet? Any idea?
Keep
To,
alive.
to start the adjacent, to make sure that there's connection between the routers.
Keep alive.
Mhm.
To check the router is active on the other end or not.
So one is keep alive. So that is known as keep alive. Okay. What else? You guys need to tell me 4 or 5 things.
To for the routing table, so it can would it drop every 300 seconds or something?
So again, keep alive is there, right?
Hello packets also help for the neighborship.
Okay. So neighbor discovery
Yes,
or
neighbor.
neighborship. Okay. What else? They're gonna advertise parameters related to OSPF. So what are these parameters? Again, some of you, maybe you don't know, so that's okay. So one is router ID, your hello and dead interval timers. Okay, your area ID. Okay, your network type, your authentication password if configured. Okay, if you are configured stub area, it's gonna have a flag which is known as stub area flag. It's gonna have DR, BDR, IPs. Okay, so some of these parameters are there. Then the other one is it gonna elects your DR and BDR. Okay, so these are the some of the things which your hello packet will do. So what is the timers? So timer is gonna be depend on your network type. Okay, network type we're gonna talk about later on. But again, if I gonna talk about broadcast or multi-access, then your timers is gonna be for hello, it is gonna be 10 seconds. And your dead interval timer is gonna be 4x of your hello. Okay, you can set it By default, it is gonna be 4x of your hello. But if you want to change it and if you want to set something else like 8x or 10x or whatever you want to set, you can set that as well. Okay. For non-broadcast multi-axis networks, your timers are relaxed where it is gonna be hello is gonna be 30, and then again it is gonna be 4x of your hello, which is 120. Okay, so here it is gonna be 40 seconds by default. It is gonna be 120 seconds. Okay. By the way, you guys will not encounter NBME networks nowadays. Now, NBME networks are your frame relay type of networks, okay, which not have broadcast functionality. Okay.
It is also for point to multi-point also, right?
Yes. So again, we're gonna talk about network types. There we're gonna talk about. Okay. And where these hellos goes, it goes over multi-point multicast address. Again, it depends on your network type, whether it wants to send multicast hello or it wants to send unicast hello. So those networks who not have the broadcast capability, they don't even have the multicast capability. Okay. So those networks will go, your hellos will go unicast. Okay. And again, guys, these 10 seconds and 40 seconds, what does it mean? What is
Like
actually means by that?
It will hold it will hold those the routes in the routing tables or in the tables before it dumps them.
Like it will wait for.
Or
So
your
basically, hello packets would be 10 seconds. Every 10 seconds, it will send a packet to make sure that the route or the neighbor is keep alive, to make sure it's alive or there's adjacency. And that timers would be to wait for that much seconds before it tells the everyone that there's no connection, so that route is dead or it's not, it cannot be connected. No response.
Okay, so if within 40 seconds did not get the hello back, it's gonna break the neighborship, right? So now my problem with that is nowadays, do you think that that much timers are okay? Do you want to wait 40 seconds to get the neighborship?
We can
To know
manually
that your
change it.
neighborship? Okay, so you can manually change it, but lowest value is 1 second of hello. That means that interval is gonna be 4 seconds. Okay, so you cannot go manually beyond this. So there is a concept which comes known as fast hello. When you run this, your dead interval now become 1 second. So if dead interval is 1 second, what is gonna be your hello interval? So it depends on the multiplier. You need to specify the multiplier in that. Whatever multiplier you're gonna put, it gonna make that one. Okay, so for example, if you put 4 as a multiplier, then it gonna send 4 hellos in 1 second. So that means after every 0.125 second, it's gonna send the hello. So multiplier value, you can go from 3 to 20. Now the problem with that thing is it's gonna increase your CPU and memory utilization because this is gonna run on control plane. Okay. So there is one more thing which is known as BFD, which we're gonna talk about later, which is bi-directional forwarding detection.
Yes.
And do you know how many seconds it gonna detect your neighborship down? What is the minimum value for that? So minimum value is 150 millisecond. Within 150 milliseconds, it can detect, and it will not even run on your control plane. This can be offloaded. So it's not gonna increase your CPU and memory. So BFD we're gonna talk about in detail. Do not worry, guys. And BFD is a protocol which you can run on over any routing protocol. You can run it over MPLS-T, you can run it over EIGRP, OSPF, BGP, whatever you want to run, wherever you can run it. Okay.
Yes. Right.
Okay, so this is all related to the hello things. But anyways, this is my first packet type. Okay, again, In the OSPF header, there is a section which gonna tells that what is the packet type. Okay, that is gonna comes. So hello packet is your type 1 packet. Okay, of OSPF. So this is, guys, we are talking about packet type. Do not confuse it with LSA type. Okay, LSA type is a different thing. This is packet type. Okay, this is CCL level of stuff I am telling you. Okay. So after this, we are having a type 2, which is known as Dbd packet. So Dbd packet stands for database descriptor packet. So what is the role of this is it gonna check for your matching LSA. And what do you understand by LSA, guys? First of all.
This is link state advertisement.
So what does it means?
Like it, all the advertisements will be in different type of LSAs. And from
So if I talk about LSA, I will simply write one word, okay, which will make your life easier. So whenever there is any update, that is known as LSA basically, in simple language.
okay.
Because here everything is link state. So whatever there is a change in any of the link information, okay, this is a information thing. It's gonna provide the information, okay? It is not a packet type. Always remember that thing. A lot of the people will say that this is a packet type. This is not a packet. This is used to tell the information. So what is the network over which I am running? So for example, if router 1 is having 2 links, okay, which are running in OSPF here as well as here. So it's gonna generate 2 LSA. Okay. And these 2 LSAs will go to your neighbor. Okay, one is for this link, another one is for this link, which gonna information, having information about link cost, link subnet, link prefix, link update, your link status, everything. So all the information it is have for that link, it's gonna send that. Okay, I'm gonna tell you where it goes, in which packet type. Okay. So, but okay, let's move on to let's come back to the database description packet. So it's gonna check for your matching LSA. So for example, what is happening here is you will have a OSPF neighbor between R1 and R2. So maybe that neighborship is the first time you are coming, or maybe that neighborship is already there. So it's gonna periodically send, or it's gonna send for the first time like database descriptor packet, which is gonna check for matching LSA. So what R1 will do, R1 send Dbd packet. Okay, first R1 will send it, R2 is gonna send. Anyways, both is gonna send to each other. But who gonna send first? That is a different part of story that I gonna tell you later. But right now, let's assume that both is gonna send the Dbd packet to each other. Now, what is the role of Dbd packet is? It is having some of the summary of your database. Okay, so Dbd packet is having basically summary of your database. So again, what do you mean by summary of database? Which means it is not having your full LSA. It is having some of the important fields which is only used to match whether the neighbor is having that update or not, whether the neighbor is having that LSA or not. Okay, so that is what it gonna tells. Okay, so for example, I am having some pages. Okay, and let me talk about, this is me and this is Akif, sorry. Okay, so I am having 100 pages. Okay, which is from 1 to 100. So these are the page numbers which I am having. Akif also have maybe Akif have 150 pages, not same. Okay. And it is having the page numbers from 50 to 150, 50 to 200. So now I am not gonna send the complete 100 pages to Akif. What I gonna send? I gonna send a information that Akif, I am having the page numbers from 1 to 100. So you can see that this is the summary of the information. Okay, I'm not sending all the 100 pages. I'm just sending the page numbers which I am having. Similarly, Akif is sending me, I am having page numbers 50 to 200. Okay, so this is guys the role of Dbd packet. It gonna sends whatever updates it is having or whatever had updates R2 is having, they both gonna exchange to each other. So now I hope you guys clear what is the role of Dbd packets. Tell me if you have any doubt.
Okay, it's okay, sir.
Okay. So now what is gonna happen is now the type 3 packet comes, which is known as LSR, which stands for link state request. So now when I got Akif 50 to 200 numbers and Akif got 1 to 100 of mine. So what I am missing? Tell me.
50 pages missing.
50 or 100?
100
I'm
to
having
200.
So what I am missing? I am missing 100 to 200, right? And what Akif is missing?
1 to 50.
1 to 50, right?
Right, sir.
So this is known as LSR. Whatever you are missing, you're gonna ask that information to your neighbor. Whatever your neighbor is missing, it's gonna ask that information from you. These are known as link state requests. So whatever is missing, you're gonna ask that. Now, okay, so first of all, tell me if you are okay with that.
Yes, sir. Sir, actually, I think the purpose of this database descriptor is like they are trying to synchronize the link state database with the neighbor, right?
Right. So that is what
Right.
I'm telling you with normal English so that you will understand that more
Yes,
clearly.
sir. Yes, sir.
So
like,
whatever you are missing in the database, you're gonna check. So again, it needs to check whether I am having that entry in my database or not.
Yes, like it will check in database descriptors like some pages are missing or not, some information are missing or not, right?
Right.
So on the basis of this database descriptors, this LSAR will be generated, right? So
Yes, LSR.
so if the information will be the same, synchronized, so then there will be like even
No,
the
no
LSAR or
LSR.
LSU.
Yes.
Yes, right. Okay.
Yes. Anyone else have any doubt, any question? Okay. So now based on that, now comes the type 4. I am writing actually all here because let it be on the one page. So type 4 is LSU, which stands for link state update. So what is happening in this one is now
This request like
okay, Akif is
yes.
gonna send me these 100 to 200 pages. Okay, and these are now full pages he needs to send. Okay, and I need to send 1 to 50 pages, right?
Yes.
And these full pages, guys, is known as LSA. So your LSA comes under LSU. LSA is not a packet type. LSA is the information which you are sending.
Yes, as you already told, like these are updates. So if we are talking about LSU, link state update. So it means like it will exchange LS.
So basically link state update is a packet type which gonna generate. Inside that you will have the LSs. Okay.
Yes.
Anyone having any doubt, anything? Okay. So after this, guys, the last packet type, which is type 5, comes. And what it do, it is known as acknowledgement. So for every LSU that your neighbor send, you need to give the acknowledgement. Otherwise, there is a retransmission timer, which is known as 5 seconds. It's gonna again send you. Because these are reliable packets, they need to have an acknowledgement. If they not get the acknowledgement, they need to send it again.
Okay. So what's the exact meaning of reliable packets?
Reliable means you need to provide the acknowledgement. Whatever I am saying to you, you need to acknowledge that you able to understand that thing.
Like
This is known as acknowledgement, reliable
yes,
communication.
yes. But it is not having any concept of TCP in here, right?
That's nothing to do with TCP.
Okay.
OSPF handle it reliable communication with this packet type.
Okay. Got it, sir.
So tell me, guys, anyone
Or-
having any doubt, any question?
So all these 5 packets are exchanged between 2 routers, regardless they are SBR or ABR or
Yes.
internal routers, right?
Yes. So if you are running OSPF between 2 routers, this is what it's gonna do.
Even if it's like running between, okay, even if it's an ABR or anything, it won't make a
Yes.
difference. Okay.
If whenever the thing goes from one area to another area, then I gonna talk about later on what is gonna be there, because every packet will not go to other area, or your every LSA will not go to any other area. Okay, like type 1 and type 2 will not go to another other area.
All right. So only the change would be between the type 4 packet, the LSU, there would be a change in the
No,
LSA
sorry.
type.
Again, do not confuse with type 1, type 2, because that is what I am talking about LSAs, not about packet type. This is
Okay.
gonna be exchange. Okay, so do not worry.
Okay. All right. So yeah. So
Hmm.
the only difference that would be in communicating the packets would be on LSU packet between 2 areas. The LSU packet would be different. It would consist of different LSA types, correct?
Yes, right.
Okay. But the LSR would be standard, the same as everything.
Yes.
Okay.
So all clear, guys, till here.
Yes, sir.
Now tell me one more thing, which is I need to add it here only. I have 100 pages, okay? Now if, for example, one page I have changed something. For example, page number 90. I have changed the content of page number 90. Then what is gonna happen?
Then database descriptor packets will check, and then it will
So
raise the
again,
request LSR and then LSU.
okay, but how it gonna be checked? There is a LSA sequence number which is gonna be used. Okay, so I'm gonna show you when we do the lab, but there is a LSA sequence number for to check this thing only. Okay, so it is a 4-byte number. It's gonna start at 0x. So this is in the hex number, hexadecimal. So again, 1, 2, 3, 4, 5, 6, 1. Okay, and it's gonna end till 7 F. So when you will have it gonna start from 1. Whenever there is a change, it's gonna send, then it's gonna increment this. Okay, so it's gonna go to 2, then it's gonna go to 3, like that, and it's gonna go to till this point. Okay. So every LSA is having a sequence number, which is going to tell whether that is a old LSA or new LSA. Okay. So if your sequence numbers are not changing, that means there is no new information. If they are changing, as soon as it get a new information, even if you shut down the link, which is running OSPF, it gonna, and you do the no shut, it gonna add the sequence number because that is a new update. You are getting my point?
Yes.
And max age is gonna be 60 minutes. After 60 minutes, it's gonna be flush. Then there is a complete exchange. Okay.
This maximum age of 60 minutes is for exchanging of
What?
So this is of your link state advertisement, which is gonna be there for your link state database. Your complete database is gonna be flushed after
Okay,
60 minutes.
Right, right.
There is a refresh also, right?
So periodic refresh is 30 minutes,
Yeah.
but there is no refresh, then max age is 60 minutes.
Yeah.
Due to any reason or ACL is blocking, if your refresh is not able to reach to the other router. So how long it should wait before removing the LSA? So that minutes it's gonna wait. Okay.
Yes.
Okay, guys. So this is all I need to tell you today, and we're gonna talk about. Just give me a second. Okay, so this is all we need to talk about today, and tomorrow we're gonna continue our class, and then we're gonna do the lab. We're gonna start with the lab as well. So tell me, guys, if you have any doubt from any point which we took today. Anyone having any doubt, any question?
Will the video be posted tonight to review?
So basically it is gonna take 12 hours because automatically it is there. Automatically, once the rendering is done, automatically it's gonna be uploaded to the portal. Okay, so mostly 12 hours it takes, but I cannot comment on that. I don't even know. But within 12 hours it is already uploaded. Okay, so you can watch it after that. Portal access, I hope you guys got the mail if you not got it. And one more thing is support@networkjourney.com. Let me write that in chat. So support@networkjourney.com. Okay, because this email is monitored by 2-3 peoples. So you will get fast reply over this
Can you
email.
post-
Okay.
Can we post that on Slack?
Slack, I am there only on Slack. So again, yeah, but backend team is also there. So you can post if you want. Okay, no issues. So Slack, WhatsApp, they usually see late, but again, your choice, wherever you want to post. But mostly if you go with this email, you will get the reply fast. Okay. And dedicated lab instructor is there. So you guys can contact if you want to set it up your lab on your system. Okay. And lab, I also gonna show you, although we gonna do it tomorrow. Okay, so there is a big topology. If I do zoom out a little bit, okay, so this is a complete big topology which has all the actually fields, but we're gonna focus only on OSPF, MPLS, BGP. Okay, so here this is OSPF, all topology related to OSPF, especially this, these 3 sections, and this one as well. Okay.
I have one question regarding
Mhm.
areas. So is areas like area 0 we say, so can we have like a router in say in India and a router in Tokyo and both of them in the same area in area
That's
0, or
yes.
it's
Yes.
or it is mainly on
No. So
geographical
nothing
base?
to do with geographical. Okay. This is a logical concept which you can put
Okay.
it all over the whole world. You can make it into one area.
Okay.
Okay. So doesn't matter. Okay. Anyone else? Any other question before we wrap up for today's session?
Thank you, sir.
Okay. Thank you, everyone. We're gonna meet it tomorrow again at the same time, 9 p.m. IST. Normally I start 5 minutes late. Okay. So 9:05 I gonna start the class. Okay. Thank you.
Thank you, sir.
Thank you, sir. Thank you.
Thank you.